See that white flash? That isn't even close to being compared with an attosecond. An attosecond to a second is as long as a second is to 31.71 billion years.
These scientific marvels are so small that it takes 10 billion of them for a flash of light to travel across this room. In fact, it would take over 79 quintillion just for light to travel 1 mile.
Attosecond physics, or attophysics, is a field of science that deals with intense laser light and atoms. This picture is just one fascinating example of how scientists were able to create and manipulate extreme ultraviolet and X-ray pulses. These pulses were vital for imaging ultra-fast processes at the atomic level. However, let's go more into depth on how these intense flashes of light actually work. First, we'll start with atoms and light. Atoms are extremely small, only a billionth of a meter in size. In terms of light, its wavelength determines their properties. This means that very short wavelengths can interact with tiny particles like atoms. Scientists create powerful lasers to make extremely short bursts of light called attosecond pulses. However, these pulses are so short that they can also quote-unquote freeze the moving electrons and atoms. However, freezing them could also knock the electron out of their orbits as they revolve around the nucleus. This process is called photoionization. In order for these scientists to take such pictures, they use a technique known as the pump probe technique. The first pump pulse targets the atoms or molecules and initiates a reaction, which is the freezing we discussed earlier. Afterwards, the probe pulse takes a snapshot of the excited state of the electrons caused from the pump pulse. These pictures are enabling a revolution of our understanding of matter. Attophysics is as close as possible that humans have gotten to observing electrons in motion. With endless applications, it's only a matter of time before we feel the effects of this field in our daily lives.